In the continuation of our topic steroid, today we will try to understand the female sex hormone, that is estrogen. As we all know, it is responsible for development of secondary sex character in women. Chemically, you can classify this estrogen in one as the human estrogens and their derivatives. They are naturally occurring. Say estrone, you can see here, estrone is there, or 17 beta estradiol is there, where in the 17th position, if it is H, then we call it as a estradiol, and if it is ethenyl group, that is C triple bond CH group, then we call it as a ethenyl estradiol. Even estriol is what again? At third position you will have hydroxyl group. Even at the 16th position you will have hydroxyl, and 17th position hydroxyl group. So what I want to tell you is the human estrogens, which are naturally occurring estrogens, are estrone or 17 beta estradiol, ethenyl estradiol, and estriol. So these are the naturally occurring, we can call it as a estrogens. Even there is synthetic type of estrogens are also available. They are non-steroidal in the nature, synthetic. We can prepare that in the labs. An example is the diethyl stilbestrol. You see here, this is the diethyl stilbestrol. Now, before proceeding to diethyl stilbestrol or other things, please understand, 17 beta estradiol get rapidly oxidized in liver. As it is getting rapidly oxidized in the liver, its effectiveness through oral route is very less. It is ineffective orally. So this the hydroxyl group at the 17th position has to be protected anyhow. That is what the structure activity relationship is. Now the 17 beta estradiol, if by the addition of 17 alpha ethenyl group at the 17th position, there is hydroxyl group. Along with the hydroxyl group, if we add the ethenyl group, that is the C triple bond C group, that is ethenyl estradiol or the mestranol. So see here, the 17 beta estradiol is converted into the ethenyl estradiol or mestranol. How this is done? Using the liquid ammonia and ethenyl group we are going to add at the 17th position. See, this adding the ethenyl group to estradiol block the oxidation and makes the compound orally active. That is the one way. Other way around is if we bring about the esterification of 17 beta hydroxy group, and even the third position also there is the hydroxyl group is there. So 17 beta and the third hydroxyl group, if we bring about the esterification, so suppose with the benzoic acid, if you do at the third position, so the compound would be 3-benzoate or propionate, using dipropionate at 3 and 17. So 3-17 dipropionate, or with valeric acid 17 valerate or 17 cyclopentyl propionate. What I am doing here, it is nothing but just the conversion of the free hydroxyl group which is present at the 3rd and 17th position, that we have converted into the esters. So what is happening because of this? There is a slow hydrolysis of these esters. What happens? These esters has to go under hydrolysis. So once they undergo the hydrolysis, the process of hydrolysis of these esters which are formed is very slow. So there is a release of free hydrogen, and the release of the free estrogen takes place over a prolonged period of time. So as there is the release of estrogen for a prolonged period of time, so esters can be very well used. Now the coming to the intensity of the activity, before that, you have seen in the chemical classification, the steroidal nucleus is not an essential feature for the estrogenic activity. Even in the view of the plant estrogens, the genistein is there, or even the synthetic estrogen diethylstilbestrol we have seen. These they don't have the basic steroidal ring. So means the steroidal ring is the prerequisite for the estrogenic activity. No, it's not like that. Even the intensity of the activity changes if the route of administration is changed. I mean, for example, if these estrogens are given through the oral route, then the estriol give you better activity compared to estriol and then the estrol. So estriol is the best if we are giving it through the oral route. And if we are giving it through the subcutaneous route, then in that case estradiol is better than estrone than the estriol. So that is important feature. That is the route of administration. So by just, if you are using oral route of administration, estriol is the best. But if you are using subcutaneous route of administration, then estradiol is best. Even the substitution, if to the ring of estrogen, if we bring about the few of the substitutions on the estrogen ring, there also there is the change in the activity. I mean, say if there is an insertion of hydroxy group at position 6, position 7, even at the position 11, I repeat once again, the substitution on the estrogen ring, where if the hydroxy group is at 6th position, 7th position or 11th position. Okay, please keep the ring structure of estrogen in front of you so that you can easily relate these things, what I am telling you. 3-4 things I am going to tell you in one go. First thing is estrogen nucleus, if hydroxy group you are going to attach at 6, 7 or 11th position, the activity of estrogen get reduced. And if the oxygen, the removal of oxygen at 3rd and 17th position, you have seen in many of the estrogen you are having the hydroxy group at 3rd and 17th position. So at 3rd and 17th position, if there is the removal of oxygen takes place, there also the activity is going to get reduced. But the introduction of unsaturation in ring B, especially ring B, the activity again get reduced. So what I want to say is the hydroxy group at 6, 7, 11 activity reduced, but the hydroxy group at 3rd and 17th position is important. If you are removing the oxygen at 3rd and 17th, the activity will be completely reduced. Even the unsaturation in the ring B will reduce the activity. The A, B, C, D. Now the D ring, if this D ring, expansion of this D ring is done, instead of that 5 member, if you make it 6, 7 like that, then even in that case also the activity is going to get reduced. However, the ring D is not necessary for the activity. If the estradiol, if you convert it into the diazenoic acid, wherein the D ring is open ring, okay, that diazenoic acid is also having the same activity as that of the estradiol. Understand? And one of the important feature is for optimal estrogenic activity, the molecule should have 8.55 angstrom distance. This is the optimum distance, 8.55 angstrom. This distance should be there between the groups that can form hydrogen bonding. Means what? The ketones are there, phenolic groups are there, alcoholic hydroxyl groups are there. So all these groups which contain the OH groups or keto groups, wherein they can form the hydrogen bonds. So the optimum distance should be 8.55 angstrom. Even in, you see the synthetic estrogen, that is diethylstilbestrol. Understand? So there also there is a 12.1 angstrom around the distances there. Even in the estradiol it is 10.9 angstrom. So That is the reason diethylstilbestrol does not have the ring structure as that of the estradiol. There is no steroidal ring. It's a synthetic compound, but still it is having the very good activity, like the same like the estrogen. It is having the activity. This is what the structural activity features of estrogen. The same notes I'll upload also, so that you can go through that notes while listening the explanation, so that you